So this problem we did yesterday, and I mentioned that we have 15 flavor of ice cream, right? And we try to get 4 flavor in our ice cream cone. So if the order doesn't matter, and ladies and gentlemen, reminder, if the order does not matter, and that's the item or the biggest challenge that you have to deal with is when you read the question, you have to ask yourself, does the order that we pick in, does the order matter? Like, do they give us specific title, specific ranking, or specific order that we need to place? If the order does not matter, that tells you that you need to use your combination. And to use your combination, same thing go, you need to ask yourself, how many total items do I have? And from that group of total item, how many can I choose, or how many do I need to choose? In this case, we have 15 flavor and we need to choose 4 of them. At number 1, they tell you that the order does not matter. And since the order does not matter, that's why I use that combination. And again, 15C4, I will get 1,356. And vice versa. In number 2, they tell you that the order matter to you, right? You want to have something in top, in the middle, and in the bottom, in the sense that you want to taste the flavor first, second, and third, and 4, or in terms of the last item, because the flavor matter, right? Because you want them in some order, some particular order that you want it, because the order matter in this case, we use a permutation. So if you can determine, and that's the hardest part of chapter 4.4, is if you can determine, are you using combination versus are you using permutation? If you can determine that, half of the material is done, right? So in this case, everybody see that we still have 15 and we're choosing 4, but the order matter, you have 32,760 different way. So in this case, this problem, this is what we have. And the reason why I go over this problem is to show you that the next problem is identical. Doesn't matter what data they give us in terms of this thing here. To connect this problem to the previous one, we still have 15 member. In the last problem, we have 15 flavor. And in this case, we select 4 members. So the data in this problem is related to the people, related to the position. The previous data is related to the ice cream, but in general, we still have 15 item, total item, and we still select 4 in terms of that, right? So again, as long as you can determine that we have the total and we're choosing this many, and if the order matter, we use permutation. If the order doesn't matter, we use combination. In this case, they give you specific title, specific ranking. So because there's ranking, because there's some order, we need to choose the permutation if they tell us, okay? So in this sense, you can see that number 1 and number 2 is very identical to the previous item, but they don't tell you, or in number 2, they tell you that the committee member, the committee, the order does not matter, right? So if they spell it out, that the order doesn't matter, we know that it's a combination. Number 1, in how many ways can this 4 position be filled? Because they give us a title, president, vice president, secretary, and treasurer, because they give a specific title, and those title hold in terms of a ranking, meaning the president have more power than the vice president have more power than the secretary, and assume that the secretary have more power than the treasurer. Because of that ranking, permutation have to be involved, and in permutation, we have 15 items, we have 15 members, and we need to choose 4 of them. And the answer is the same as the previous one, which is 15P4, we have 32,760, right? And in number 2, they tell us that the ranking does not matter. There is no order involved, doesn't matter. We just need 4 committee members. And because there are 4 committee members, the order doesn't matter. That's why we use the combination. So first of all, before we move to number 3 and number 4, anyone have problem on how to use your calculator? Anybody have question on how you use your calculator? I went over how to use a calculator last time, but anybody does not know how to utilize your calculator at this moment here? Okay, so all of you know how to find the NCR and the NPR. And if you remember last time, I told you guys that if you have two number, one big number, one small number, most of the time, always, the big number will be your total, right? Because there's no way if you have 4 people and you can choose 15 from the group of 4, right? There's no way if the total is 4 and you choose 15 of them, right? It's got to be 15 choosing 4. But now let's take a look at number 3 and number 4. They write it a little bit different, but they say 4 people on a student counselor are Sam, Justin, Brittany, and Rashawn. What is the probability that Sam is a president, Brittany is a vice president, Justin is a secretary, and Rashawn is a treasurer? So looking at this item, whenever they ask you for probability, and just like before, they just want to connect a probability with counting or with permutation versus a combination problem. But in order for you to find a probability, reminder that you need to find the total. You need to know how many total ways certain things do, right? So in this case, because they give us a specific title, because they give us specific ranking, we know that the order matter. And let me ask you this question here. When you do this probability, how many ways can this 4 position, this 4 president, vice president, secretary, and treasurer be few? But do you agree that they want it to be specifically Sam president, Brittany vice president, Justin secretary, and Rashad is a treasurer? Because they're given this specific name, there is only one specific way that this thing can be filled, which is this is the way, which is Sam president, and so on and so forth, right? So there's only one way. And to find a probability, is always is what we're looking for. We're looking for this one particular way that Sam is president, Brittany is vice, Justin is secretary, and Rashad is treasurer. We're looking for this one way out of the total possible way that we can form 4 people where the ranking matter, which the ranking matter 32760, the one way out of that. And that is always the case for you to find the probability is what we're looking for over the total. In the sense of the problem that you probably will see in your homework. But question with number 3 here. And number 4, they ask you, what is the probability that Sam, Justin, Brittany, and Rashad are the 4 committee member? Because they don't give us specific, order or specific ranking, we know that this is a combination problem, right? But because they ask us probability, same idea go, you have to ask yourself, how many ways can these 4 people be selected? Again, doesn't matter which one hold which position. In general, I just need to have these 4 people in this group of committee. And to have these 4 people in this group of committee, do you agree that there's only one way? Right? Let's say if I have Jennifer cannot be in this group because this is the only one way that these 4 people is in this committee. Yes, Sam can be president, Brittany can be vice, Justin can be secretary, Rashad can be treasurer, or vice versa. Rashad can be president, and how many mixed match you want to do, that's fine. But there's only one way that these 4 people can be elected to be a committee, which is this 4, that's it. If one of these 4 is not make it into the committee, then that is not this item here, okay? So it's not 4-way, right? It's only one way that we can select these 4 people. And to find the probability, we need to take this one way, one specific way that these 4 people over the total ways that 4 people can be chosen. So in general, this is what we have, 1 over 1,365. And ladies and gentlemen, please do not, it's not 1 out of 15, right? 1 out of 15 meaning you choose 1 member out of 15 member. That's the probability of you choose one member out of 15. This thing here is because they ask you how many ways that you can form this item. And to find out how many ways, we have to know the total possible ways. And from the total possible ways, this is the one way that we can have this 4 people, okay? If any other that substitute one of this 4 is not this way, okay? So there's only one specific way, that's this 4 people, and that's it. So first of all, question in terms of how I find number 1, number 2, which is the different ways to form the 4 people. One of them, the position matter. The other one, the order does not matter. And from there, how question with 3 and 4. All right, let's take a look at this item. And I want to, I want you to, someone asked me a question about this question on the homework, and I didn't know that I put this question from the homework, but this question is basically your homework question. Your homework question can generate a little bit different. Instead of 7 and 9, they can say 10 and 2 or something in that nature. But if you read this thing here, they say a committee consists of 7 women and 9 men. 3 committee members will be chosen as an officer. So let me ask you this question here. In this committee, how many people in general, disregard of their gender, how many people in general? Do you agree that we have 16 people in general? 9 women, 7 men, 9 plus 7, the total people, regardless of their gender, we have total in this group is 16, okay? And this is what they ask you is we need to find 3 committee members. So let me ask you, if you select 3 people from this group of 17 people, or 16 people, I'm sorry, 3 people from this group of 16 people, does the order of the 3 people matter? Hopefully you can say no, because they don't give us any particular position or ranking or order, right? They just say, I have this group of people, 7 women and 9 men, which in turn, I have a total of 16. And now I need to choose 3 of them, right? So the order doesn't matter. So you should have an idea that the order does not matter. We will use a combination problem. So before taking a look at at number 5, forget about number 5 for now. One thing is, on your homework, they might skip part 1, part 2, part 3, and they jump into part 4 and they ask you, what is the probability that all of the officer are women? So I want to point out that they might not write it this way. They might not ask you part A, part B, part C. If they do, it's good, right? They build you up until you get to part 4. But if they just jump in, if they just give you a committee consists of 7 women and 9 men, 3 committee members will be chosen as officer. What is the probability of all the officer or woman? If they were to jump into just what is the probability, you need to remind yourself that there is a hidden part. In order for me to find a probability, first I need to know how many total possible way out there that I need to choose. And from those total possible way, how many ways can I specifically choose just the woman? Okay, so that's the idea, that if they don't give you a step-by-step, you need to know that you need to find those items in order for you to find number 4. Okay, so let's take a look at number 1, right? In how many different ways, in how many different choices are possible? So like I mentioned, they don't specifically ask you, is it woman or man? They just, in general, how many ways can you choose 3 people? That's it, right? So in how many ways we can choose 3 people, we have to know the total is 16, because 7 plus 9, and we need to choose 3. And the order does not matter. That's why we use combination. And if you type this in your calculator, we have 560 different ways. Meaning, again, doesn't matter if it's all 3 women, 2 women, 1 man, 2 men, 1 woman, or all 3 men. Doesn't matter, it's in this 560 ways, or 560 possible ways that we can choose. Okay, so again, the number of choosing 3 people from a group of 16 in general is 560, where the order does not matter. And again, why the order does not matter here? Because they don't give us any specific title like president, vice president, or CEO, project manager, or again, if they don't give us any rank and any item in terms of ranking, order, or title, then it's a general combination. Okay, and now number 2 and number 3, they specifically tell you just take a group of women and take a group of men, right? They ask you how many different ways that you can choose, how many different choices can you choose. The all officer and all of them are women, meaning we need to choose 3 of them, 3 officer or 3 people, and these 3 people is just considered just the woman. So again, I have 7 women, and from the group of 7 women, I need to choose 3 of them. This, ladies and gentlemen, guarantee, right? 7 choosing 3. This guarantee me that the 3 people I choose, 3 of them must be a woman, because I just take out the woman. I have 7 women and choose 3 among the 7, meaning there are 35 ways that I can form this committee, and all 3 of the people in this committee is women. Okay, and vice versa. Number 3, I have 9 choosing 3. Why? Because this is the number of ways that I can choose 3 people, and all 3 of them are men. Okay, and if you take 35 and plus the 84, if you add them together, that will give you 119. As you can see, there are 560 total possible way. And if you add the 35 and the 84, that will give you 119, meaning they are the leftover. If you take 560 minus 119, there's the leftover of different combination of 2 women, 1 man, and 2 men, 1 woman, right? The 2 extreme is 35, just a woman only, 3 women by themselves. The 84 is just the 3 men by themselves, right? There is a mixture, which is the leftover from 560. Those are the mixture of 2 women, 1 man versus 2, and also 2 men and 1 woman. But again, we don't need to know those remainder. This is what we need to know is, how do we find the probability? What is the probability that all of the officer are women? In this case, just like before, to find the probability, we need to know what we're looking for, and we're looking for the number of how many ways, how many opportunities that I can get that all three officers is all women, over the total possibility in general of select 3 people. And in this case, everybody see that I have 35, which is, this is the 35 women divided by 560 in general, how the 3 way or 3 people I can choose from the group of 16. And if I divide this, I get 0.0625. And like I mentioned to you guys, on your homework, they might not ask you part 1, part 2, part 3. They might not, but if they don't ask you part 1, part 2, part 3, and they jump into part 4, you have to know that you need part 1 and part 2 in order for you to answer part 4. Okay, you have to do it by yourself. They might not ask you, but you need to do it. Don't just put, a lot of people, they put in 3 over 16. Again, it's not 3 over 16. 3 over 16 is basically the probability of choosing 3 people out of 16 people. This asks you how many ways you can select 3 items. Okay. Question with number 1, number 2, number 3, or number 4 here. Question of how to taken just this small item, right? Taken just this small 2 sentence and convert to this 4 answer. Any question? All right. If you don't have question, let's take a look at this number 5. And number 5, they ask you, what is the probability of at least one of the officer is a man? So at least one, if you remember the at least one word, right? That's your keyword. You know, that's one of the keyword from our probability, which is the word or, the word given, the word and now the word at least one. And if you remember the at least one formula, the at least one formula tell me that I need to find the probability of none. Probability of at least one man is equal to 1 minus the probability of none of the 3 people or men. So do you agree that none of the 3 women or men is the same as all 3 of them are women? Do you agree that all 3 women meaning none of the 3 people are a man? So if we know this, as you can see, it's kind of build up. We need 1, 2 to do number 4, and then we need number 4 to do number 5, because how do I find about at least one man? All I need to do is take 1, the total possibility, minus the probability of 3 of them, and none of them are a man. And again, it's equivalent to say none of them are men, meaning it's the same as all 3 of them are women, right? Which give me 1 minus 0.065, and this will give me the probability of at least one man will be 0.9375. And if you want to, if you take 560 minus 380, not 385, 35, if you minus that, you will get 525. 525 meaning those are a way that you can have 1 man, 2 men, or 3 men, right? Because 35 is all women. All women meaning it does not include any man in it. So if you take the total ways minus the way that just the woman, you will give the leftover, which is 525. And that 525, if you take 525 divided by this total, you will get the same thing. In the sense that, again, the worst case is none of the 3 are men. So again, the same idea, none of the 3 are men. I mean, none of the 3 are men is the same as all of them are women. Okay, so it's just a different wording, but it's equivalent, right? But question in terms of how I find this, at least one of them are a man. And if they ask you for at least one of them a woman, you have to find, again, all 3 men, find that probability, and then 1 minus the men out, okay? Question with this example here, question with any step, procedure, or the answer. All right, if you don't have question, let's take a look at the last problem I have. And like I mentioned earlier, this is all I have for today. I will save the rest of the class time for you guys to work on your chapter 4 material so that you can prepare for your test. Let's take a look at this item. And this item, I think, is bring a lot of problem to a lot of student prior. So hopefully I can go over this to clear the item up. So this is your question they ask you is a computer password consist of 9 character, replication or allow. And now they ask you, that's all they say. And they ask you how many different passwords are possible if each character might be any lowercase letter or digit. So first of all, hopefully you guys see that this is not a permutation problem or combination problem, but rather this is the fundamental counting principle problem. How do we know? Because again, unless they tell you that I have 9 characters and I need to choose 4, or if I have 9 characters and I need to choose 2, or something in that nature, then basically they ask you how can you come up with this password if there's 9 characters, right? Just like the license plates, the Louisiana license plates, how can you come up with the license plate? Well, we need 3 letters and 3 numbers. But in this case, they say you that a password. And again, this, as you can see, this password is back then. Right now, for the Delgado password, it's like 16 characters, and then one of them have to be a capital letter, and one of them have to be a other symbol and stuff like that, right? But let's take a look at this item here. How many different passwords are possible if each character might be any lowercase or digit? So if you look at this item, you have to ask yourself, how many different slots do I have? How many different slots do I need to create this password? Because there are 9 characters, I need 9 different slots. And if I need 9 different slots to create this 9 character password, at each particular slot, how many options can I choose? So do you agree that at each particular slot, there are 36 options you can choose, meaning you can choose 26 letter, from 26 letter, or from the 10 digit. And again, 26 plus 10, that will give you 36 total choice that you can put in this 9 different slot to create this password. And if you look at this item here, like I mentioned, we have 9 slots, right? The first slot, you can choose from A to Z and also from 0 to 9. The second slot, the third slot, the 4th, the 5th, the 6th, the 7th, all the way up to 9. So in the sense, your password, like I saying, well, I didn't say it for this class, but your password can be A723, B2C, something in terms of that nature, right? So 36 times 36 times 36 times 36 times 36, 9 times, that would give you a humongous number, right? 1.015 something times 10 to the 14. 10 to the 14 basically tell you that this thing here, you move 14 places to the right. So this number is very humongously big, okay? So this is the total ways that you can come up with any particular password that it consist of 9 characters, meaning this password can be 6HJ E5, 6, and M3, right? Again, any of this letter, any of this item here is in this total 1.016 times 10 to the 14, okay? And again, how do I get that? Because I know that I need 9 different slots, and at each particular slot, I have 36 total choice to put in there. I can only put 1, but I have 36 choice. 1 from the 36, 1 from the 36, 1 from the 36, okay? And again, why I use 36? Because replication, right? I can reuse the number. I can use 666 9 times if I want to, but you don't want to create that password, right? Question with number 1, how I got this answer here. And now, same thing go, how many different passwords are possible if each character might be any lowercase letter? So now they restrict us, right? The restriction is I only need a character in terms of the letter. I don't need any digit, right? I can only use letter. And in this case, if I can only use letter, there are only 26 letter. That's all. My only choices that I can pick. Again, I can pick from the 26, but there are 9 slots to create this password. And to create this password, I need to take the 26, the choice that I have, time itself 9 times. And if I do that, I have 5.4230 times 10 to the 12th. Okay, so the difference between number 2 versus number 1 is number 1, you can use any letter and any number at any location. Number 2, you can only use a letter at each of your location. Okay, now question with number 1 and number 2 here. Now, number 3 is a little bit different, and they ask you how many different passwords are possible if each character might be any lowercase or digit, and at least one of them must be a digit. So looking at this thing here, the at least one, right? The word at least one, you have to have an idea, or the at least one, they want you to connect this idea to the idea of the probability, or if you remember the complement of at least one. The at least one is the total minus the probability of none of them have the item we're looking for. okay? Because if the item that none of the item we're looking for, then that's excluded out in the at least one, because at least one is you either have one number, two number, three number, four number, five number, six number, 7, 8, or 9 number, right? Your password can be 24392912 7, right? Something in that nature, or 9999999 of that, right? But to using that property, at least one is the same as the total minus the item that does not exist, the item we're looking for. And to do that, do you agree that number one is the total item I have? Number one is the total possible password I can come up with, minus number two is just the letter. Number two does not have any digit in it, right? Number two is the number of password I can come up with that does not have any digit in it, meaning none of the password in number two have a number in it. And that is what I have. The total minus this, the total is 36 raised to the 9 power minus 26 raised to the 9 power. And this will give me the at least one. At least one of the slots have a digit in it, okay? And again, ladies and gentlemen, please using this item here, 36 raised to 9 power minus 26 raised to 9 power in your calculator. Do not using this number 1.016 times 10 to the 14, because this number is rounding up. This number is too big. Your calculator does not list every single digit out there. So if you round it up and you use the round up number, your final answer might not be correct. So remember, to find the answer, you only round up at the final step. You don't round up in the procedure, okay? But to go back to the idea of at least one, everybody see that at least one is the total minus the none. And the total is number one, that is total possible password I can get. And number two is the password that does not include any digit, which is none of the password in number two have a digit, which is, if I subtract, that's what I have. So if you don't have question, number three, if you glance number four, if you glance on number four, they ask you, what is the probability, right? What is the probability? And reminder, to find the probability, just like before, just like all of the items, to find the probability, we need to find the total of what we're looking for over the total of every possible item we have. So a computer, it generates, so we click on this computer generates 9 random passwords. And each of them are equally likely have to any 26 letter or the 10 digit. Replication allowed, and they ask you, what is the probability that the password will contain all letter? Meaning, again, you have this computer, you press, say, generate me a password, and the probability that this computer generate you the password and all of the 9 item is just letter itself. And to do that, how many ways, right? How many ways can I choose just the letter, only letter? Do you agree that number two, those are my total number that just letter by itself? Number two answer, this answer does not have any digit in it. So all I need to do is take number two, which is 26 raised to 9 power, those are my letter, divided by the total possible password that I can generate, which is 36 raised to 9 power. And if I divide that, I will get 0.0535. And again, 0.0535 is still a usual event. You know, the cutoff is 0.05, and this is 0.03553, which is bigger than 0.05. But we will get to the unusual event in more detail later. But looking at this thing here, to find any probability, just like before, to find any probability, we need to look for what we're looking for over the total possible item. Question with number 4 here. And lastly, they ask you, what is the probability of at least one of them is a digit, right? A computer generate require that your password, if your password just letter, they say, sorry, you need to include at least one digit in it, right? One number. So they ask you if 9 characters are generated at random, what is the probability that they form a valid password? So what is the valid password? The valid password here is they have to have at least one digit. And to do this thing here, to find this probability, all you need to do is how many ways that I can get at least one digit. We know this is the number of ways we can get at least one digit. And we can take that and divide it by the total. Or we can take, if we know the probability of none of the probability is, I thought I typed this thing here first, but I typed this item first. So to find the probability of at least one is basically 1 minus probability of none. And like similar to the previous problem, none man is the same as all women. So this right here, the probability of none of the password contain the digit is the same as all of the item contain the letter. So you can take 1, which is the total probability, minus the probability of all letter to give you this answer, which is at least one of the character is a digit. Or you can take the result in step 3, divide by the result in step 1, because this right here is the total item that does not contain the well, at least one. This is the total item that contain at least one digit, right? At least one digit here and over the total. So in the sense of this thing here, you know, is, and that's what math is, right? They give you a simple, somewhat simple concept, and the challenge is they want you to take that simple concept and build into all this abstract item, right? And that's what you will see a lot in this class is we go with all this, simple, find this, find that, but then later on they just add on more information and ask you, can you use all this simple concept and analyze the bigger picture of the item. But question with this slide up here, question with number 1 through number 5, how I got the number, how I work with my calculator, how to input in your calculator, or how to utilize your calculator. Any question in general, ladies and gentlemen? Well,